Hello, advanced algebra students, and welcome back from a spring break. Here is our first video lesson as we return to the start of the fourth quarter, where today we talk about applying the compound interest formula to different investing situations. So the nice part about this area in this section is that a calculator and or Desmos is approved, meaning when you get a mini test on this, you are allowed to use calculator and Desmos. As a matter of fact, you're going to have to. So I hope you had a good break, and I hope you viewed our quick little intro video to fourth quarter. Again, as we start, we really have 2+ chapters. We need to finish chapter 7 this week, which is lesson 7.4 and lesson 7.5. And then we have to do chapter 8, all on inverse functions, and chapter 9 on log functions, which is called logs. Looks like we are probably going to have a final exam this semester. And so far, we talked about chapter 10 from trigonometry, unit circle, law of sines and cosines, as well as chapter 6b, all of that different quadratic stuff. So we really got to make sure we're focused and finishing strong, because this is, the semester grade is what gets reported on transcripts, GPAs, and all of that stuff. So this week, as we look at what we're doing, again, we're going to talk about compound interest and compound interest formulas today and tomorrow. Wednesday, you'll have a target practice on that, and then we'll introduce you to the next lesson, 7-5. We'll talk a little bit about going back into history of an interest problem, and then a review day on Friday so that we can have a mini test on Monday the 12th. So again, the fourth quarter is a challenge, a lot of new topics, new content, the weather gets nice, maybe some sports and different activities. You got to make sure that you're focused and finishing strong. So it's really time for us to start talking about money, right? And when we talk about compound interest and money and growth, we're talking about what's called a compound interest formula. And so one of the examples that we're going to use is from page 9 of the packet, where Mrs. Wallen decides to invest $1,500 into an account that is paying 5% annually. So she's going to get 5% every year. Question number 1 wants to know how much will she have in her account at the end of 1 year. Well, in order to figure that out, we have 1,500 times the 5%, 0.05, and we're going to add back to that the amount that she started with, which was 1,500. All right, so if I go over here to Desmos, I'm going to have 1,500 times 0.05, the 5%, plus the 1,500 that she started with, and you'll notice I get a value of $1,575. $1,575. Now, there's a formula that goes with this over here, that the amount that we make is equal to our principal value times 1 plus the rate to the power of t, where t stands for time, because that's how often we're getting it. And we can use that to help us answer B. How much will she save at the end of 5 years? Well, the principal amount that she started with is 1,500 times 1 plus her rate. 5%, though, we have to make sure, if you remember back to algebra, that we stick that in the problem as a decimal, to the power of t, in this case, to 5 years. And so I can go over again to Desmos and clear all of that up. 1,500 times 1 plus my rate to the power, to the power of 5. And you can see, we went around to the nearest penny, 1914.42. 1914.42. So $1,914.42. So in general, we have this principal, which is our starting amount. We have a rate for showing how much interest or money they're making, and we have a certain time. But what do you think might happen if we change the interest from being every single year to being what is called compounded semi-annually, where she gets it more than once a year. Hopefully, you understand that that means we are going to make more money, right? If they give us the interest more, we'll make more money. And so anytime you have an opportunity for compound interest, take advantage of it because you're going to make more money. So here's a great formula. I would strongly suggest that you write it down because in algebra, we only worked on interest every year, and now we get it what's called compound interest, where they do it more than just once per year. So it's a very similar formula where we have A equals P times the parenthesis 1 plus R over N parenthesis. This is N times T up here in case you can't read that. N times T. So the A value equals the amount. Let me type this. I think it'll be nicer if I type. This is our amount of money at the end. And P is the principal or the starting amount. R is the rate, which is your percent as a decimal. We got to make sure it's a decimal. N is the number of times compounded. How many times are they giving you interest? And T is time in years. How long are they giving you this interest for? So make sure you understand what those different values stand for. This is our ending amount, our principal or our starting value. R is the rate. N is the number of times you get the compounded interest. And T is still how many times a year. So annually, right, if we look at the values that we might have to use for N, that compounded part, annually means you get the interest once. Semi-annually or biannually means you're going to get that compounded twice. Quarterly means you're going to get it 4 times a year, once for each of the 4 quarters in a year. Monthly, there's 12 months in a year, so you're going to get interest every month for 12 months. And daily, if you ever get a chance for that, I would soak that one up as fast as you can because that would be 365. And so we use those numbers for the value of N here and up there. All right. Now, we also need to remember, though, that our rates need to be changed into decimals, right? And how do we turn it into a decimal? We move the decimal spot to left. It's the same as dividing by 100. So 2 to the left. 6.25%. If I move it 2 to the left, 1, 2, it would go here, and I needed to add a 0. 0.0625. That's the same as 6.25%. 3%. Move it once, move it twice, and I get 0.03. 0.75% would be 0.0075. 0.5%, 0.5%, moving it backwards twice would be 0.005. And then 10.05%, if I moved it backwards twice, will be 0.1005. And those are the things we need to understand how to use as a decimal for our percentage or the rate. So let's try a basic example of what this looks like, okay? A certain coin has a value of $1.17. The value of that coin has been increasing at 9% per year, every single year. What is the value after 5 years? All right, so the A, that's our final value. That's what we are looking for, so we're going to have to figure that out. The P, or the principal, is the starting value of this coin. The rate is 9%, and I'm going to write 9%, but when I use it in the formula, we're going to use 0.09. N, how many times does it earn its interest or gain value? That's per year. So that's a 1 because of per year. And how many years are we looking at its value? After 5. So if we use our formula, A equals P, which is $1.17 for its principal, times 1 plus the rate, which was 0.09, over N to the power of N times T, 5 or 1 times 5, which is 5. So Desmos is going to become your friend, and you want to make sure you're utilizing Desmos to punch that in. All right, so we're going to go over there. I just got to write this down so I make sure that I am actually typing in the exact information that it wants. Let's clear what we had, and here we go. $1.17 times 1 plus 0.09 divided by 1 year, because we're getting that interest every year, to the power of 5 times 1, which is 5. And you'll notice $1.80. Whenever we're dealing with money, we're going to round it to that nearest hundredth or that nearest penny. So the amount at the end would be a value of $1.80. Now you can use Desmos on the mini test that'll be on Monday, but I want to make sure you understand that I need to see this formula. We want to see and make sure that you're punching the information into the formula correctly first. Let's try a couple more where we have some different compounded interest. Whoops. We need to go to the next slide, Mr. G. All right, so here we go. We're going to only record our final answers, but I'm going to ask you to fill out these different values. So pause the video in a moment and fill out what is A, P, R, and T for both of those. Go ahead and pause and try and fill that out. All right, let's look at the first one. Gina deposited $1,500 in an account that pays 4.38% compounded quarterly. What will the balance be in 2 years? So $1,500 for P. The rate is going to be 0.0438. It is compounded quarterly, which means our N should be 4. And our time, how long are we looking at it? For 2 years. So for 2. All right, I'll figure that out in just a moment. Let's go down to the Goldmans. They have $12,278 in their account. The bank is going to give them 3.5% interest, so 0.035 on their savings, compounded monthly. They get it monthly, so that's an N equals 12. And find the balance after 3 years. So there's my 3. And so now we're going to want to go over to Desmos and punch each one of those in so that we can find their value in total. So let's look at the first one. So I'm going to clear 1,500 times 1 plus 0.0438 divided by 4, right? We're getting that interest of 4.38% 4 times. So we divide it by 4 to the power of that 4 to the power of 4 times 2. Right? Don't forget, you've got to multiply that. You maybe would have seen that it was 8. So we get 1636.55. 1636.55 for Gina. And then if we look at the Goldmans, on the other hand, again, they're getting it at 33.5% compounded monthly. Let's change our formula up, clear all of that. The principal was $12,278 times 1 plus the rate divided by the compounding, which was 12, all to the power of N times T. So it was 12 months times 3 years, meaning we get the interest 36 times, or a final value of $13,635.22. 13,635. 13,635 and 22 cents as a final value after those 3 years. So hopefully you understand where I'm grabbing the different variables, P, R, N, and T, and then all I'm doing is using them in this equation inside of decimals to find their final value. Today, you're going to be working on a few introduction problems related to finding that compound interest. Please make sure you try the practice problems, and if you have any questions, reach out. Otherwise, until next time, everyone, stay safe.